let's talk about the fundamental theorem of calculus part 2, okay? This is extremely important, okay? So basically, you know the meaning of definite integral, right? Definite integral means the net area of your function between a to b, right? So like if your function f is positive function, then definitely just area under the curve from a to b. That is the meaning of integral, okay? So as we talked about it, since it is like if it is curved, there's no way to find the area under the curve directly, right? So that's why we construct the rectangles. But like it's kind of painful process, right? Because it takes some time, right? But this one, the fundamental theorem of calculus part 2, it is really powerful method, okay? So we can get the area under the curve or net area between a to b by algebraic way, okay? But the thing is, you must have the antiderivative of your function, which notated by capital F, right? So like in other words, if it is like, integrable, then we can apply this one, okay? So basically this one, okay? So you have function f of x and interval a to b. If you have antiderivative of function f, which is capital F, then you can get the area, net area under the curve from a to b by this calculation. Just capital F of b minus f of a. Okay, so let me show you let me introduce one important notation for this one, and we're going to use big bar notation from this point. Okay, here we go. So integral a to b f of x dx will be written by antiderivative and big bar notation and a and b. This notation means we're going to plug in b first into f and plug in a and subtract. Okay, but keep that in mind. This is the area under the curve or net area under the curve between a to b. Okay, so let me give you the example. Okay, simple example. Okay, look at that. It is polynomial, right? So we know it is integrable, right? And we can easily find antiderivative of given function, right? So the first step to use the fundamental theorem of calculus part 2, and we have to find antiderivative of given function, okay? 5x squared, it is 5 over 3 x cubed, right? And then negative 4x, which is 4 over 2 x squared plus 3, and like this notation, okay, big bar and negative 1 and 0. Okay, let me simplify a little bit before plugging this. Okay, it is equal to 5 over 3 x cubed minus 2x squared plus 3 and negative 1 and 0. Okay, then we're going to plug in 0 first. Okay, it is equal to 0, 0. Oh, give me a second, I made a mistake. Okay, but you had to catch up. Okay, it was 3x, not 3, right? When you plug in 0, 0, 0, 0, all zeros, right? That's it, right? And then we're going to subtract the function value by plugging negative 1. Plug in negative 1. Negative 1 cubed is negative 1, which is negative 5/3. And negative 1 squared is positive 1. Then now it is negative 2. And negative 3, right? So that is equal to negative 5/3 and negative 5, which is negative 15 over 3, and negative 20 over 3. So your final answer is 20 over 3. This is the way to use the fundamental theorem of calculus part 2. Let me give you a couple more examples about the fundamental theorem of calculus part 2, right? Here we go. So the first step is we have to find the antiderivative of given function, okay? So to do so, let me write as a power form is equal to integral 1 to 2 x to the negative 2 dx, right? Then by the fundamental theorem of calculus part 2, it is 1 over negative 1 x to negative 1 and big bar notation 1 to 2. Let me simplify the inside, okay? It is minus 1 over x and 1 and 2. That's it, right? And plug in 2 first, okay? Negative 1 over 2. And actually you can put negative outside, okay? It doesn't matter, okay? But or you can just include for this calculation, it doesn't matter, okay? It is negative 1 over 1 is equal to negative 1/2 plus 1. So the answer is 1/2. That's it. It's a really simple process, right? And what about next one? Look at that. It is equal to antiderivative derivative of given function. It is 8 e to the t, right? N big bar, and ln 3 to ln 6. That's it. Again, you can put your coefficient x outside for this calculation or include, doesn't matter, okay? So like for this case, like let me like put your coefficient outside, okay? 8 and e to the t like this way, right? Then it is equal to 8 times, plug in ln6 first, e to the ln6 minus plug in ln3, e to the ln3, right? And do you remember this one? E to the ln6 is 6. And e to the ln3 is 3. 8 times 3, which is 24.